We're recording. All right, here we go. All right, so as far as functions go, right? First, we work with functions to start by looking at a relation and seeing if it represented a function or not. Yesterday, we finally got to evaluate functions by finding things like f of 3 and f of -5. Today, it's all about being able to read the graph of a function. Can you look at the graph and pull important information off of it? So what they're going to do is they're going to give you the graph of a function. Normally, they'll call it, this is the graph of y equals f of x. They just say, in general, it's the graph of a function, but they don't tell you the mathematical rule that it follows. They don't tell you y equals 2x plus 5 or x squared minus 3. They don't give you the mathematical rule. If you're going to find inputs and outputs, you're going to find them by taking information right off the graph. So guys, I told you, a function tells a story, right? F of 3 equals 5 means that 3 goes in and it spits a 5 out. Every single ordered pair that lives on the graph of a function is telling you a story. This is the ordered pair 6, 2. So that is telling you that when 6 gets plugged into function f, guess what number it spits out? It spits out a 2. We have no idea what actually happened to that 6 to make a 2 come out, but we don't care. That's what it tells you, though. The graph of a function tells you when this number went in, that number came out. So you don't actually have to know the rule to answer these questions. Okay, so guys, if it asked you to find f of -3, so -3 would go into this function as x, what y coordinate would this function spit out? So guys, go on your graph to where x is -3 and find the corresponding point. It's right there. This is the ordered pair -3, 2. So that means that when -3 goes into this function, who's the function going to spit out? 2. The answer to this question is 2. So it's actually easier than when they give you the written rule. Because when they give you the written rule, you got to plug -3 in and do the math. Here you don't have to do the math. The graph is like a cheat sheet. It tells you, oh look, -3 went in, 2 came out. So it should be easier, okay? As long as you know how to read it. All right, now it says find f of 0. So when 0 goes in as x, what y value is this function going to spit out? So go to where x is 0 and find the corresponding point. Guys, it's actually right here. When x is 0, what's the y coordinate? 0. So guess what? When 0 goes into this function, who is this function going to spit out as y? 0. Guys, if you're here, you can say the answer. That way we're all kind of in this together, okay? And you're here, you can say it on the meet too. All right, look at f of 6. That means when 6 goes into this function for x, who's the function going to spit out? Go to where x is 6, find that corresponding point. It's 6, 2. So when 6 goes in, who does the function spit out? 2. Everybody? 2. Jack, you okay? Mackenzie? 2. Thank you. I want Angel to feel like he's by himself up here, although I'm glad he's here, else I'd be talking to myself. All right? All right, now look at the next one. The next one says, find f of 4 plus f of -1. First, we have to get a number for f of 4. So when you plug 4 into function f, what number comes out? So here's x is 4. There's the ordered pair. Who comes out when 4 goes in? Everybody? 2. Yeah. So it's 2, and then we're going to add it with f of -1. Now you got to get a number for f of -1. So when -1 goes into function f, there's the point. It's -1, 1. So when -1 goes in, who's the function going to spit out? 1. So now our answer is, what's 2 plus 1? 3. All right, give me a thumbs up at home if you're okay. Are we following? Nice? Yes? Okay. All right, now they threw a curveball at you. Now they're going to reverse it. Watch what they do here. It says, for what value of x? So now your answer is going to be an x coordinate, okay? Did f of x equal -2? Well, I warned you guys yesterday, if you're not a fan of all of this f of x, this fancy function stuff, just remember at the end of the day, f of x represents y. So if they want f of x to equal -2, they're basically asking you for y to equal -2. So now go to your graph and find a y-coordinate of -2. Y is equal to -2 right there. So find me a point that has a y-coordinate of -2. Guys, there's a point right here that has a y-coordinate at -2. The answer to this question is his corresponding x-coordinate. So what was the x-coordinate when y was -2? X was 2. So the answer to this question is you would have had to plug a 2 in to make a -2 come out. All right? Everybody okay with that? Yes? All right, I'm going to add another question. I'm going to say, for what value of x does f of x equal 1? I'm going to do another one. Remember these good old days, Dan? Yeah. Yeah. What you do to go back, right? All right, so guys, look at this one. For what value or values, because there could be more than one answer, of x, does f of x equal 1? So again, f of x is 1. So we're trying to find out what x values make y equal 1. So go to your graph and find y is 1. Y is 1 right here. You're trying to find points that have a y-coordinate of 1. Well, guys, there's a dot right here that has a y-coordinate of 1. What's his corresponding x-coordinate? Anybody? -1. So x could be -1. But guys, there's also another dot over here that also has a y-coordinate of 1. That means there's another x value that could make 1 come out. Does anybody know your best estimate what x value this is right in the middle of 3 and 4?
3.5.
I would say 3.5. On your homework, it'll be much more clear. You will not have to worry about guessing. But I would say that's 3.5. Okay? So you could get more than one answer to these when you're trying to find the x's. Okay? Now on Delta Math, do you guys remember on Delta Math when you got more than one answer, you had to hit that plus sign so that second answer box popped up? Do you remember when you did that? So you're going to have to do that if you get more than one answer again. Everybody at home, remember on Delta Math when you needed one answer, you had to hit the plus sign to get that second answer box to pop up? Give me a thumbs up if you remember that. Because if you do, if you have 2 answers, you're going to need 2 answer boxes. Last night on Delta Math, I discovered that if you tried to write the answers like this, if you tried to put them in one answer box and put -1 and then comma, the comma automatically makes a second answer box pop up. So if you tried to do it that way, you'd still be writing it correctly. All right, and then 3.5 would go in your other box. All right, perfect. Let's go to the new notes for today. So guys, these notes are in today's Google Classroom. If you want to be able to bring them up or print them out. And I'm going to skip down to the example 5. This one first. This is the question I took right out of the SAT booklet. So if you look at this question, I wanted to skip down to this one because it's just like the one we just did, except they took it up a notch. Instead of giving you the graph of one function, they've given you the graph of 2 functions on the same coordinate plane. So guys, this blue squiggly one, this one, represents the graph of f of x. So any questions you want to ask about f, you want to look at the squiggly graph. This upside down parabola, this upside down U, if you will, the red one is the graph of g of x. So any questions about g, you want to look at the red graph. Okay. All right, so guys, the first question says, find f of 1. So that means we want to know when you go to function f and plug an x value of 1 in, what y value does it spit out? So since it's talking about f, look at the blue, the squiggly graph. If x is 1, find me the matching point on the blue squiggly graph. It's right there. Guys, what's that y-coordinate right there? Everybody?
1.
1. So that means when 1 goes into f, it'll spit a y value of 1 out. All right? Let's find g of -1. Now you're going to g, you're plugging -1 in as x. Who does G spit out? So G is the red graph. So now we're looking at G. So when x is -1, what point is on the red graph? It's all the way up there. And what's the y coordinate at that point? 3. So that means G of -1 is 3. Thumbs up if we're okay at home. Yes, we're hanging in. All right. All right, you guys do part C. I want you to find f of 4 plus g of 0. First, you got to get a number for this, then you got to get a number for that, and you got to add them together. Just be careful that you're looking at the correct graph. F is blue, G is red. Again, the thing that I like is that there's no math involved, right? You don't got to worry about plugging something in and PEMDASing it. It's great. All the information is right on the graph. All right, so it says f of 4. So when x is 4 on the blue squiggly graph, what's your y coordinate? Everybody? 0. Then we're going to add it with g of 0. So now when x is 0 on the red graph, what's the y coordinate? 2. So the answer to this is 0 plus 2, which is 2. Excellent. Thank you so much, guys. All right, I'm going to do this one with you just for time-saving purposes. Now we're going to find f of -3. So when x is -3 on the blue graph, my y coordinate is, everybody? 1. Then we're going to subtract g of 1. So when x is 1 on g's graph, y is? -1. So now you have to take 1 and subtract -1, which turns into plus. So you also get an answer of 2 for this one as well. Okay? All right, now they switch it around on you. Now they throw you the curveball, right? Now we're going to reverse it. Now they want to know for what value or values, so there could be more than one answer, of x, does g of x equal 2? So again, g of x represents y. We want to know, when does g of x spit out a y coordinate of 2? So guys, it's only asking about g. So forget the squiggly graph. Pretend the blue squiggly graph isn't here. We're just looking at the red graph. Okay, so where does y equal 2? Y is 2 right here. So I can see there's more than one dot that has a y coordinate of 2 on the red graph. We need their x coordinates. So guys, what's the x value that makes g of x equal 2 here? X is? 0. And there's another ordered pair that has a y coordinate of 2, and his x coordinate is? -2. So the answer there would be 0 and -2. They both make a y value of 2 come out of the g of x function. Okay? Everybody okay there? We're all right? All right, now I'm going to go back up to the top and start these notes for real. Okay. All right, so guys, here's the deal. We've technically already done this in our notes, but I wanted to do it again because I had, maybe it doesn't sound like a lot to you guys, I had over 6 students text or email me about the homework last night on Delta Math, the last section, when you were asked to find the domain and range visually from a graph. We did this in our notes the first day at the very, very end, and I warned you guys with the asterisk is that you have to write your domain and ranges as sandwich inequalities, that you couldn't possibly list all of these x and y values. I don't know if students forgot that or they missed that part of the notes, but I had a lot of questions by not just one, by many on this part of the homework. So I wanted to go over it again. All right, so guys, this question pertains to this graph. These questions pertain to this graph. So here we go. Is this the graph of a function? So guys, look at this graph. We know that the vertical line test says if you can draw a vertical line anywhere over this graph and it only touches one point at a time, it's definitely the graph of a function. So guys, look, if you draw a vertical line anywhere over this graph, it only touches it how many times? Just once. So is that the graph of a function? Yeah. Definitely. This is definitely the graph of a function. Now, they want the domain and range. Who did we say the domain was going to be? All of the what values? X, right? Perfect. So that means x's move from the left to the right. I wish you guys could just sit here and list them and make the list and call it a day. The problem is because the dots are connected, there's just infinitely many x values that live on this graph when you think of all the fractions and decimals, and we couldn't possibly write them all. So we're going to have to write this as a sandwich inequality. So x moves left to right. What's the farthest left this graph ever went to? What x value? 0. All the way over to the right, what's the farthest right it ever touched? 8. So now you have to say that the x values are any number in between. So the way we write that is a sandwich, little number, 0, always a less than, and since it didn't have an open circle where x was 0, put a line under it. And then we're talking about x, always a less than, and then the big number was 8. And since 8 did not have an open circle, put a line under him. Now, I don't know if you guys noticed on Delta Math, Delta Math was giving you two options as an answer. They gave you the sandwich inequality, or they gave you interval notation. So I don't know if anybody saw anything that looks like this, kind of like an ordered pair. That's interval notation, and we don't teach you that until pre-calc. So you don't have to worry about this answer. It just means the same thing as this, okay? All right, now I want the range. The range of the y values, and y so up and down, right? So up and down, you want the lowest spot to the highest spot. What's the lowest number this graph ever went to? -3, beautiful, all the way up to 3. So y is any number in between them. So little number, always a less than, and since it was not an open circle, put a line. Now we're talking about y, always a less than symbol, up to the big number, 3. And then since it wasn't an open circle, give yourself a line under it. Okay, moving on to the next one. Look at this one. This was used to be a question on your quarterly. This was a first marking period quarterly question, except we don't have a quarterly this year, so isn't that nice? All right, look at it. It wants to know, is this the graph of a function? Guys, does this graph pass the VLT?
Yes.
Totally. This is definitely the graph of a function. All right, as far as domain, the x's, guys, it goes all the way from an x value of who? 10 all the way over to an x value of? 16. X is any number in between 10 and 16. So give me your best sandwich inequality. Little number, less than, there's no open circle, so everything should have a line, less than or equal to 16. Okay? And then the range. Here's the beautiful thing about the range. Guys, what's the only y value that lives on this graph? 80. So you can say your range is y equals 80. Now, on Delta Math, it probably just tells you to put 80 in the answer box. Sometimes they'll even have you write it as like the set of numbers, but the only number in the set is 80. So those little curly braces. Okay? All right, perfect. I want you guys to do number 3. Tell me whether or not it's the graph of a function, and then get me the domain and range. Oh, man. Number 4, if you try it, it's a major curveball. Because number 4 is a little bit different in the sense that you will not be writing sandwich inequalities. You may be writing an inequality, but it's not a sandwich. So that's a little bit different. I don't even know if we're going to have time to get to that one today. All right, first of all, is this the graph of a function, guys? Does this pass the VLT?
No.
Not a clue. This is definitely not a function. No circle is passing the vertical line test. It fails it everywhere, right? It hits the graph in more than one spot. I mean, if I draw a vertical line right here, it fails. Guys, that means that when you plug a 3 into this function, it could make this y value or that y value come out. That's no function, all right? So that's a no. I want the domain, right? Our x's, what's the farthest left it went? Negative 1 all the way over to
-5.
+5, right? So any number in between. -1 less than or equal to x less than or equal to 5. Again, because nothing had an open circle. I think Delta Math had some open circles, so those symbols wouldn't have gotten a line under them, but ours are good. All right, and then the range, the y values, who's the lowest number? -8 all the way up to?
-2.
You guys are really leaving Angel hanging here. You're all else in the classroom. All right, so now, any number in between, little number, less than or equal to y hat, less than or equal to big number. And again, no open circles, so we put the line under the symbols. All right, I don't know if I'm going to have time to do this one. I just want to show you what's different about this one. The difference here is every graph we've seen so far was capped. It had a start and an end. Like here, it went from -1 to 5. It had a start, it had an end. It went from -8 to -2. It had a start, it had an end. Everything was capped. This graph has arrows on it for the first time that we're seeing. So the arrows imply that this graph is going to go on forever and ever and ever and ever and ever and ever. So now there's no cap. So we won't be writing a sandwich inequality because technically one end doesn't have a cap on it. So I can't say it's in between this and that. So the domain and range get to be a little bit different. I have 3 minutes. Let me see if I can do this one. So guys, let me show you the domain. First of all, it does pass the VLT, so it is a function. All right? But as far as the domain goes, like the x's, guys, think about it. This graph, it's going and going and going, which means the x values that live on it are just going and going and going. Anybody know who's at the very end of our number line over here? Negative infinity. And then who's all the way over here on this end? Positive infinity. So basically they're saying that the x values that live on this graph go all the way from negative infinity to positive infinity. But we can't put that like as the sandwich inequality. You're not allowed to write infinities in your inequalities. So what they're saying is any number in between is on there. So that's all real numbers. Every real x value lives on this graph. So the domain is all real numbers. Which, again, on Delta Math, they might say that goes from negative infinity to infinity, like an ordered pair, but that's interval notation, and we don't write that yet. All right, and here's the range. Guys, do you agree that the y values, they don't get capped here? Who are the y values shooting off to? All the way up to infinity. But who's the lowest y value on this graph? -3. So technically, to be a y coordinate on this graph, you just have to be any number bigger than who? -3. So in this case, you just say all the y values on this graph are y's that are greater than or equal to -3. You don't have to sandwich it because there's no cap on the other end of it to sandwich it in between. So again, that's a little bit of a curveball. That's not on your homework. I just wanted you guys to be aware of graphs like that. Your homework is mostly on reading the graph of a function, okay? All right, guys, excellent. If you have any questions on the meet, please feel free to stay. Otherwise, you do have a new Delta Math assignment tonight that is due tomorrow night, and yesterday's Delta Math is due tonight, so make sure you get that done. All right, otherwise, I'll see you tomorrow. Everybody's virtual tomorrow. I'll see you on the meet. Do you guys have any questions for me? No. You guys are okay? All right. Woo! And let me stop the recording. Ah, the mask is killing me. You too.
Bye.
Thanks, guys.